here, but there is still some new stuff, so be sure to be paying attention. You should be on page 53 and 54 of your Know It notes, lesson 4-3. It has 2 sides. Let's get started. First thing, writing a function rule. Now, you've all done this in the past, right? We take from the words or from a table, we take the function and we write the algebra for it. So we want to know how we get from the input value, which is x, to the output value, which is y. And you don't need to write that part down, but you might want to write down what's at the bottom here about how to do the guess and check part, which is to think about the KISS principle. Keep it super simple. Most of the rules aren't going to be really complicated. So you're going to try adding or subtracting a number from x first. Could you just do x minus 2, right? If subtraction or addition doesn't work, then try multiplying by a number, like multiply by 2 or 3 or 5, something small. It's not going to be multiplying by 77, right? Think small. And then if neither multiplying nor just adding or subtracting works, then go ahead and try a simple combination, like doubling it and then add 2. Doubling it, add 3, something like that. So let's try a few. Okay. And you can just do these with me out loud. You don't have to write them down. I think you'll get the idea. And we're going to do more of these when you get back to class. So we've got our input values and our output values. And you're thinking, all right, how do I get from x to y? By the way, when we write these, we'll write them as y equals, right, x plus something times something, whatever that's going to be, right? It's always going to be an equation in y. And it looks like, you figured it out yet? Okay, I'm seeing, right, decreases of 3. So I'm thinking it's going to be y equals x minus 3. Take away 3 from y each time. Sometimes it's easier to look at the 0 and the positive values than the negative values, only because it seems more intuitive. Let's change tools and we can see if we're right. And we are. Let's do another one. Okay. So now there's not as much data. It makes it a little trickier, right? Add 3, that's not going to work, right? What if I multiply by 4? No, that's not going to work, right? What if I, right, I'm done. Multiplying isn't going to work by itself, so now I'm thinking it's got to be something 2-step. Maybe multiply and then add. It's usually a pretty common thing. See if you can think of something with multiplying and adding. I think I see it now. Think you got it? I'm in a race. Did you get y equals? You better have gotten that part. 3x plus 1. Right. Triple the input value times 3 plus 1 makes 4, times 3 is 9, plus 1 makes 10, right? And you're there. Let's do one more of these together, and then I think that'll be it. Okay. Now this one, right? We go from 1 to 4, 3 to 2, 5 to 0. This is a little confusing. They're clearly, most of the time, they seem to be, right, decreasing, okay? But it's backwards. I don't know if you guys can hear on the cheering in the background. The Giants just won the game, and I can hear Miss Akala's class cheering. As you're listening, you'll know that I'm recording this today, right before you view it. Okay. Now this one is hard, right? It actually, you're going to subtract x from 5. Very tricky, right? To either have negative x plus 5 or 5 minus x. Either one would work. That's a hard one. Okay. This I do want you to write down. These are 2 of the vocabulary words. I don't know that I would write them separately on the 2 lines there. I think I would just write this whole sentence because the definition of the 2 things is really, they're really together. They're integrated. So on those lines up at the top, write this down by where it says dependent and independent variable. The value of the dependent variable, which is usually the y, depends on or is a function of the value of the independent variable, which is usually x. Okay, so the value of the dependent variable, usually y, depends on or is a function of the value of the independent variable. So the independent variable, the easiest way I know to try and help you remember which is which, is to think of it as the independent variable is the one that you choose the value of and plug in. So maybe you choose, you're going to check what happens when x equals 1 or when x equals 2. Okay? And that's the x value, right? The independent variable, it's x, right? It's on the horizontal axis because it's the x value. And then the dependent variable, that's the one that you calculate, okay, based on the independent variable. So the dependent variable gets calculated. The independent variable is the one that you chose and plugged in. Okay. This is important because when you start doing word problems, you have to choose which is the independent variable and which is the dependent variable. Many algebra word problems, their favorite independent variable is time, right? If 1 hour passed, what happened? If 4 hours passed, what happened? You have to have them correct, otherwise your whole graph is backwards. Kind of changing topics, we will talk more about independent and dependent variables in word problems, but we're going to do that in the part 2 of the lesson. Function notation, and this is the third vocabulary. Function notation is using this f parentheses x, and it's all spread out here, so I think this is a better place to look at it. F of x. We say that because the dependent variable is a function of the independent variable, we abbreviate function with just the letter f, and because the independent variable is x, we put it inside parentheses and it goes right next to each other, f of x, a function of x. F is not multiplied by f. F is not a variable that you can fill in. X is a variable that you can fill in, but not f. F is just representing the word function. So x plus 3 is a function of x. And really all this does is y is replaced by f of x. Okay? Exact same meaning, right? We just take the y out, and when it's a function, we can instead say f of x, function of x. Okay? And I want you to turn to page 54, actually. And we're going to put this in there now that you've kind of listened about it. So the equation in function notation, in that box there, I want you to write f of x equals x plus 3, what I'm underlining in pink right now. And then you're going to go ahead and pause the video, and you're going to create your own table of values in just a second. And, 4 values is enough, right? Choose 2 negative and 2 positive. In 7th grade, I like to call those the fave 5. And then you're going to make a quick little graph. You can just kind of sketch it. You don't need to put graph paper there or anything. And you're going to graph the information from your table. So go ahead and pause the video to do that. And now that you're back, we're going to talk about one more thing, which is evaluating functions. And you can put this either below the vertical line test back on page 53 or below the boxes where you just were on page 54. We don't need that vertical line test thing because we already did that. When you evaluate functions, this is just plug and chug problems. You put in the input value and you number crunch, you chug to get the output value. And remember, the f is not a variable. The f is just standing for the word function. So if I tell you that the function is 3x plus 2, right, and I'm looking for you to find f of x when x equals 7, we're just going to take 7 and replace x with it. And we can write it this way. The function's value at 7, so we put it in for x there, equals 3 times 7, replacing the x, plus 2. And then 21 plus 2 equals 23. We can find that function's value at a lot of different numbers. This also asks us to find it at -4. And you should be writing this down. Maybe go ahead and pause the video for a sec and see if you can figure out what it's going to equal at -4. Now that you're back, you plug in -4. and you get 3 times negative 4 is negative 12, plus 2 makes negative 10. So the function's value at negative 4 is negative 10. We could take this information, we can write ordered pairs with it, right? 7, 23, negative 4, negative 10. Now you're not actually in this problem being asked to write the answers as ordered pairs, but I want you to see that that's what's coming out of these. When you evaluate a function, you're getting an ordered pair, right? You plug in the x value, the independent variable, you get the dependent variable, the y value, which is, in this case, for the first one, 23. And I think I probably have one more, but I think actually let's save those for in class, and I think that's going to be it. We're going to stop there. We'll do a few more evaluate function ones when you come back to class. If you want more of them, you can take a quick look in your textbook. If you have any questions, jot them down now so you'll remember to ask me tomorrow.